Hello dear friends, welcome to my channel. Today's discussions is complex analysis problem. The value of I divided by 4 minus pi integration dz divided by z cos z where mod z equals to 4 is equals to this. So my fz is 1 by z cos z. Z cos z equals to 0. So that implies z equals to 0, otherwise cos z equals to 0. So when cos z equals to 0, then equals to cos 2n plus 1 pi by 2. So z equals to 2n plus 1. So n equals to 0, then z equals to pi by 2. It means 3.14 divided pi value is 3.14, then z equals to 1.57 when z equals to 3 pi by 2, n equals to in here 1, then it is 4.71 less than 4. So this is, I can't take this because as mod z is equals to 4. So my circle, I draw a circle, my circle radius is 4. So point should be in here, not outside the circle. Inside the point should be inside the circle. So 3 pi by 2 lie outside the circle, and it is 0, pi by 2, minus pi by 2 are lie inside the circle. So residue. Now we count residue by the Cauchy's theorem. Residue at z equals to 0, limit z tends to 0, z minus 0 into z cos equals to 1. So friends, z equals to 0, z. Now I have to find out limit z tends to. So friends, residue at z equals to 0 equal to 1. Similarly, we have to find out another that residue at z equals to pi by 2. We have limit z tends to pi by 2, z minus pi by 2 divided by z into sine pi by 2 minus z. Very simple, pi by 2 minus z. Okay, so we get this value is minus 2 divided by pi. Residue at z equals to is minus 2 by pi. Now residue at z equals to 2 equals to limit z tends to minus plus pi by 2 divided into plus z equals to minus 2 by pi. So answer should be integration dz into z cos z equals to 2 pi I 1 plus, sorry, this is not plus, this is minus 4 pi equals to pi I into pi minus 4 divided by pi. So pi 2 pi I pi minus 4 divided by pi equals to pi minus 4 equals to 2. So my answer is in here 2. Next problem is number of solution of the equation. Number of the solution of the equation z cube plus 3 into mod of z bar whole square divided by mod z. So equals to 0. So take r z equals to r into e to the power I theta. Let z equals I theta. So by the de Moivre's theorem, e to the power 3 I theta into plus e r square e to the power I into minus 2 theta divided by, so r cube equals to e to the power theta 3r to the power I 2 theta minus equals to 0. So friends, we can see r divided by e to the power 2I theta into r square e to the power I 5 theta plus 3 equals to 0. So mod of r square e to the power 5 theta mod equals to mod minus 3 equals to 3. So mod of r equals to 3 as mod theta equals to 1. So friends, you see that e to the power I5 theta so equals to 1. That means cos 5 theta plus I sin 5 theta equals to 1. So cos theta plus I sin 5 theta equals to 1. So cos 5 theta equals to here our angle is minus, not because r is 3. So cos 5 theta equal to minus 1. So theta belongs to minus pi comma pi. Theta belongs to minus pi comma pi. Theta r pi 2 pi 3 pi 5 pi minus pi minus 3 pi. This is the answer. So total number of solution is 5. Number 3. Consider the function f such that c tends to c given by fz equals to e to the power z. Which of the following is wrong? So fz equals to e to the power z is non-constant poly non-constant analytic function non-constant analytic function. Now the open mapping theorem. What is the open mapping theorem? Open mapping theorem, suppose that f is analytic and non-constant in an open set G, open set G, then FG is open. Then FG is open, open, open. So friends, whatever you see that that fz less than 1, then it is not open set. This option is not open set. This option is false, and others all option is correct. This is correct. Let fz equals to e to the power z minus 1 for all z belongs to C such that e to the power z does not equals to 1. F is meromorphic. Obviously F is meromorphic. The only singularities of F are poles. This is also correct. And F has infinitely many poles on the imaginary axis. This is also correct. And each pole of of F is simple. This is also correct. How friends? Because you have to learn that meromorphic function. Meromorphic function. Friends, you can see my another video where I have also already discussed that what is meromorphic function. But it is revision, revision, that what is meromorphic function. Number one, if fx is meromorphic function, meromorphic function, then the function has a set of a set of singularities. Okay, the function has singularity. Function has pole singularity. Okay, this is very better. This is pole singularity. Collection of pole singularities. You cannot get any other singularity. Only pole. Okay, so e to the power z minus 1, e to the power z minus 1, you can write e to the power z equals to 1. So according to the theory, you can write e to the power I pi, and you can say z equals to plus minus I pi. So you see that imaginary number, this is the axis, and you see that this way you get imaginary axis. Okay, so you get only imaginary pole, imaginary axis. Each pole of f is simple. This is correct because isolated pole, and the only singularities f are poles. So if it is meromorphic, then it is isolated. The singularity is pole. Now next we will solve this problem, e to the power. So friends, you see that fz equals to e to the power minus e to the power 1 by z, and formula is that e to the power minus z is formula 1 minus z plus z square divided by 2 factorial minus z cube divided by 3 factorial plus z to the power 4 divided by 4 factorial minus up to infinity. So e to the power minus z equals to 1 minus z. This is the formula. So e to the power minus e to the power 1 by z equals to 1 minus e to the power 1 by z plus e to the power 1 by z divided by 2 factorial minus e to the power 3 by z divided by, and up to this way we can get up to infinity. So residue at z question is at z equals to 0, so we have to find out. So now you see that e to the power 1 by z equals to 1 plus 1 by z plus 1 by z square divided by 2 factorial plus up to 2 by z e to the power 2 by z equals to 1 plus 2 by z plus 4 by z square divided by 2 factorial up to plus infinity. So up to we can say that we can write that e to the power minus e to the power 1 by z equals to the coefficient of 1 by z equals to minus 1 by z plus 2 by z divided by 2 factorial minus 3 divided by z divided by 3 factorial up to this way, and we can say that minus 1 by z we can take common, minus 1 by z equals to 1 by 2 factorial 1 by 2 factorial minus 1 by 3 factorial up to infinity. So we can write this way, minus 1 we can write, and after that this equation it can be written that e to the power minus 1 up to minus 1. So my answer is coming in here. This answer is e to the power e to the power minus 1 minus 1. This is my total answer. Now question number 6. Let C denote the unit circle and centered at the origin. Find the value of 1 by 2 pi I 1 plus z square whole square, and the integral is taken anti-clockwise along C equals to, now 1 plus z square whole square equals to 1 plus z square into 1 plus z bar whole square. Okay, I can write this way, and after that 1 z equals to cos theta plus I sin theta, so I can write, and z bar equals to, so I can write this way that 1 plus cos theta plus cos 2 theta plus I sin theta plus, because you can write this 1 plus z square equals to 1 plus e to the power I theta plus e to the power 2 I theta. I can write this way, and I can write this way. Hence we can see that 1 plus z plus 1 plus z square centered at the 0. This is very important questions, that centered is in circle, center is 0. So z equal, another important information is the unit circle. You see, this is the unit circle, means radius r equals to 1. So z equals to 1 by z bar z bar z square equals to 1 by z bar whole square, our z bar whole square. Okay, so mod of 1 plus z square mod equals to 1 plus 1 plus z square and into 1 plus 1 by z plus 1 by z whole square. This is the I can write this way, and after that if I will multiply integration c, then I can multiply. What I get 3 plus 2z 3 plus 2 by z plus z square plus 1 by z square into dz. Okay, 1 by dz. So we get this value, and after that they ask that while the integral is taken anti-clockwise along c equal. So no problem, my answer is coming that residue of the function, residue of function at of 1 by z. So my answer is coefficient is 2, so answer is 2 pi I into 2 is equal to, so my answer is in here 2. 2 is my answer. Next, let gamma be the circle given by z equals to 4 e to the power I theta, where theta varies 0 to 2 pi. Then this is the value we have to find out, e to the power z into z square minus 2. So friends, how can I find out? So friends, my fz equals to e to the power z divided by z square minus 2z. This is my fz. Here I can write this way, e to the power z into z minus 2, and my pole order z equals to 2 and z equals to 0. This is my order. My order is 1. Must remember. So residue at z equals to 0, limit z tends to 0 0 z minus 0 into fz equals to limit z tends to 0 e to the power z divided by z equals to minus 1 by 2. Similarly, residue at z equals to 2, limit z tends to 2 e to the power z divided by z. E to the power z divided by z, that means e square divided by 2. So friends, whatever I get minus half, and this is my value. So I can write this value is 2 pi I by Cauchy's theorem minus half plus e square. Okay, I hope I can clear e square by 2, and it can be written that pi I square minus 1. So now we will go to solve next problem. Suppose that f is non-constant analytic functions and defined over C, then which one of the following is false? F is unbounded, f is sets, open sets into open sets. There exists an open connected domain U on which f is never 0, and this is the restrictions U. F modulus f restriction U attains its minimum at some point of U, and the image of f is dense in. So friends, now the question is that if it is minimum, attains minimum, okay, must remember attains minimum. If U, this is if it is minimum, if it is minimum, if it is minimum, then it is then it is constant. Minimum, then it is constant. By maximum modulus principal. So friends, I hope I can clear that. Obviously, so it is which is following is false, so obviously this is false. But now I have to check that it is another are false or not, that I have checked. Question we are taking, this is the my inner question. F is non-constant entire function over C, analytic function. So we take fz equals to e to the power z, fz equals to e to the power z, open mapping theory, and fz does not equals to 0, if f is non-constant analytic function domain D, f is non-constant function domain B, then U is open connected, then U is open connected, and fz does not be for all z belongs to U. So the image f is dense in C, this is also true, and f is unbounded, this is also true. F sends open sets to open sets, this is also true by open mapping theory. So my answer is 3. 3 is false because I have open mapping theorem. Open mapping theorem. Next we will go to solve question number 9. The value of integral e to the power z divided by z square dz, where mod of 1 minus z equals to 1. I have to check that the value of integral, that 1 minus z is the outside region or inside the region. Pole is z square minus 1 equals to 0, so that implies z equals to 1 and minus 1. I have to see that it is inside the pole, outside the pole. 1 minus z equals to 1, so we get that z equals to 0, and another is 1 minus z equals to minus 1. So we get z equals to 2. So valuation. So if I put in here z equals to 1, then I get 0. 0 is less than 1. So 1 is out. 1 is inside the pole, and minus 1 is outside the pole. Must remember, friends, minus 1 is outside the pole. So e to the power z divided by z square minus 1, z minus 1, limit z tends to 1 equals to e to the power square divided by 2. This is my answer. So my answer is, sorry, e square, sorry, no, e divided by 2. So 2 pi I into e divided by 2 equals to pi I e. Okay, next question number 10. Let f such that z mod z less than equals to less than 1 c be a non-constant analytic function. Which of the following condition can possibly satisfied by f? F such that mod of z less than 1 tends to c. Let fz equals to e to the power z non-constant ana non-constant analytic function, then mod of f divided by 1 by n equals to e to the power mod 1 by n equals to e to the power 1 by n less than 2 to the power minus n, and for all n belongs to capital N. And for n equals to 1, if 1 by n equals to 1 by 2n plus 1, and if minus 1 by n equals to 1 by 2n plus 1, this condition cannot be satisfied because I take the example e to the power e to the power z, then this is not possible. But this possible, you will see that e to the power 1 by n is equal to less than 2 to the power minus n. This is also not possible. So this is not well, and this is not possible because a 1 by root over n, this is not possible. So only one possible is number option 1. We can take that fx fz equals to z square, then we can get this portion is possible when if let we take fz equals to z square, then f 1 by n equals to f minus 1 by n equals to 1 by n square. This is possible. This is possible, and otherwise we can't see that any case it is not possible. This portion is possible only n infinity. If n tends to infinity, then it is possible. So only option 1 is correct and others are false. Question 1:11. Consider the map phi such that c minus 1 c given by phi j. So friends, phi j, so friends, now we try to solve this problem. Consider the map phi such that c by 1 minus 1 tends to c, given that phi j equals to 1 plus j divided by 1 minus j. Which of the following is true? So whatever you see that phi j equals to 1 plus j divided by 1 minus j, and c minus 1 is my domain. Okay, domain is c minus 1. Now phi j into 1 minus j equals to 1 plus j, and phi j minus j into phi j equals to 1 plus j. So j equals to phi j minus 1 divided by phi j plus 1. So range set is set is c minus 1 minus 1. C of my option D is correct and others all are wrong. So question 12. Question 12 is, let omega be an open connected subset of C. Let E equals to Z1, Z2, Zr subset of omega, and f such that omega is a function such that f restriction omega minus E is analytic. Then f is analytic on omega. If f is continuous on omega, f is bounded on omega, f is for every j. So friends, you see omega be an open connected subset. Subset of C. Omega be an open connected subset of C, and E equals to Z1, Z2, Zn. and if such that omega tends to C, and if restricted if restricted omega is analytic at, so there is a point, suppose this is my set and there is a point z1 z2, you get this kind of point. So now we start singularity. Three type. One is poles, number removable, and essential. So singularity are three types. E is does not equals to essential singularity. Essential, then the Laurent series should be, then you can get any finite point. You get infinite. So the possibility is does not equals to essential. So possibility is poles. Poles are removable. Do two is possibility. So F is number one question, that F is continuous on omega. This is correct. But F is bounded on omega. F is bounded on omega. Bounded on omega as a open connected of C, that it is not bounded. It is not bounded. Number 3, for every j, if m belongs to j and am equal to z minus zj to the power m is Lorentz series, Lorentz expression if at zj em equals to 0, for m equals to a minus 1 minus 2 minus 3. So friends, must remember that when Lorentz series, now we will discuss the negative portion, means Lorentz series is summation m belongs to zj and am zj z minus zj whole to the power m. Similarly, we get another, that m belongs to zj b minus n, means this term in Lorentz series, and z plus zj whole to the power m. Okay, this term means this negative portion if finite. If negative power of Laurent series, if negative power is Laurent series is finite, then it is pole. Infinite infinite, then it is essential. And no negative power, then it is removable. So friends, here is equals to 0. So friends, in here you see that function is analytic, analytic when power is when m equals to -1 minus equals to 0, 0 when m equals to -1 minus 2. So correct. Number 4, for every j, if m belongs to z and am and z minus zj to the power m is Laurent series expansion at zj, then e minus 1 equals to 0. So friends, e minus 1 equals to 0. This does not mean e minus 2 equals to 0. That's not equals to 0. So residue is 0. This is not mean that function is analytic. This is mean function is analytic. So this option is not correct. Number 13. Show that if such that C is analytic function, then F is polynomial if for every point alpha belongs to C, any point alpha belongs to C, if Z is equal to power series expansion at A, then n equals to 0 at least one n. Okay, so first that I can write A equals to summation n equals to 0 to infinity a n z minus a whole to the power n. A n equals to 0 or at least one n, or at least one n. If n a divided by n factor a equals to 0. That implies if n plus 1 equals to 0 for all n. So the value of fz equals to a0 plus a1j minus a z up to whole to the power n. So friends, any alpha belongs to C is power series expansion at a n equals to 0 for at least one n. This is true. And second is also true. Limit n tends to infinity, z tends to infinity, mod of fz equals to infinity. And third option is also fourth option is equals to true. Now how? Now I just try to explain. Theorem: mod of fz is entire function is entire function and mod of fz less than equals to m r to the power n. If such that c tends to c, so mod of fz less than equals to m mod of z whole to the power n, and then fz is polynomial maximum degree n. Then fz is polynomial maximum degree n. And for number 3, mod of fz less than equals to m, entire function is bounded plus bounded that implies it is constant. Liouville theorem. Entire function is bounded plus constant. Is that is fz is polynomial. So we can easily say that it is also bounded. Limit z tends to infinity. Z tends to infinity. This is bounded. That means it is constant function, and this is also correct, as this portion is correct, because z tends to infinity mod then it is infinity. In here it is constant function. In here it is constant function. So constant function is always polynomial. Next friends, Next we will go question 14. Let D be the open unit disk and centered at 0 in C, and f such that D tends to C be analytic function. Let f is equal to plus iv, where u and v are analytic imaginary functions, parts of f. If fz is equal to summation n k to the power n f is, then f is constant number. If f is analytic, how can we solve? Number one, fz equals to u plus iv, fz equals to u plus iv, and fz equals to summation n to the power n. So f bar is analytic. Analytic if in the real imaginary parts of f. Let D be the open set and centered on C0, and f such that D be analytic, then let f is u plus iv and v are real and imaginary parts of f. If fz is the power series of f, then f is constant. Okay, f bar is analytic. If f is analytic, you have equal to uz. Okay, f is constant. If f is analytic, u bar you have equal to uz. The set of n belongs to infinite. And okay, now we will discuss that which portion is correct. Our correct portion is number one. Number one is correct. Number two is correct. Number three option is wrong. Number four option is correct. F bar z is equal to u minus iv. So this analyze. But z is equal to, so but here equation ux equal to minus minus of minus vx. Okay, here equation ux equal to analytic ux equal to vy by cr. Equation here equation ux equal to vy and uy equal to minus vx. Now in here ux equal to minus of minus vx. So sorry, uy is equal to minus of minus vx. So whatever is it, and ux is equal to minus minus vy. So we see that vy is equal to 0. So so my first option is correct. F bar is means F bar is analytic. Then it is constant functions. Constant functions is analytic. I show it through the Cauchy sequence. Now you have less than equals to uz. How can we prove this, friends? Now let's go to discussions. Real part, real part, imaginary part, and imaginary part is bounded. Real part and imaginary part is bounded. So you have less than equals to uj by the and z for all z belongs to D. So by the Louis-Philippe theorem is a bounded function, bounded analytic function, analytic function is constant. Is also correct. Now we will discuss third option. For third, you see fz equals to cos z. Example, counter example, counter example. So I did theory cos z, and you see equal to a3 into a1, a3, a5 equals to infinity. Equals to 0 up to infinity equals to cos z. So cos z is not constant functions. We discuss second option. Second option is the identity theorem. Identity theorem. Fz so friends, gamma equal to fz divided by z minus a whole square equals to 0. So in here f dash a equals to 0 because the formula Cauchy's theorem that this is the circle and this is a equals to half and this is my a equals to half and f dash a equals to 0. So if a equals to constant because the Cauchy's formula that it is when the identity theorem. What is the identity theorem? Identity theorem is that the formula is that gamma fz equal to z minus a whole to the power n dz equals to 2 pi I f n minus 1 a divided by n minus 1 factorial. I think this type of formula we are studying in complex analysis. If n minus 1 divided by n minus 1 factorial. Okay, in here 2 factorial n equals to 2, so this value is f dash a divided by 1 factorial into 2 pi I. So this portion is 0, so f dash a is equal to 0, so f a is equal to constant. So this option is correct. Next friends, we are going to discuss question number 15. Question number 15. Which of the following statements are true? If ak is bounded, then ak z to the power k defines an analytical fixed function unit disk. Question number 15. Which of the following is statement are true? Summation ak z to the power k and mod of ak whole to the power 1 by n less than equals to capital A. Supremum, so supremum limit n tends to infinity mod of ak whole to the power 1 by n less than equals to 1. So r equals to 1 and supremum limit n tends to infinity mod of ak whole to the power 1 by n less than equals to m to the power 1 by n. So n tends to infinity means it is 1. Our first option is that if ak is bounded, then akz to the power k defines analytic function unit disk. This option is correct. Is bounded, then define analytic functions unit disk. This is correct. That analytic function unit disk. This question is suppose this type of questions. This type of questions that domain D, the D is a mod of a to the power half. Less than equals to half to the power, sorry, less than equals to half. Number 2, if akz to the power k defines analytic functions on the open disk that must converges to 0. This option is false. Number 3, if fz, akz, zk and gz, bk, zk are two power series functions whose radius of convergence is r1, then the product of fg has a power function series representations form on open unit disk. This option is, and this option is wrong. If ak is z2 has a radius of convergence 1, then f is continuous on this function. This is the proof that r1 is bounded, ak is bounded, then limit n tends to infinity, r equals to 1. The open disk when it is 1. So first option I have already shown, and second option is must converges to 0. It is totally wrong because I have proved that it is unit disk. Okay, so it is not must converges to 0. Number third, that whose radius of convergence are 1, then the product f dot g a power series in representations. So this option fz equal to 1 minus z and z square up to infinity. So infinity ak z to the power k. AK mod of AK and BK mod of BK equals to mod of AK and mod of BK. So this is 1 into 1. So I can prove this option is correct. And number 4 is radius of convergence is 1. Then f is continuous on this option I have told wrong. Now question ends, you see that mod k less than equals to 1. Okay, so I have already proved that defines analytic functions is bounded, then it is analytic functions. So bounded means mod of z less than equals to m. M may be any integer, may be any number. So how it is possible only for this option? Next problem, friends. Next problem is let C be the red circle of radius 2 centered at the origin oriented of the anti-clockwise directed, then the integral z divided by z minus 1 whole square is equals to. I have to find out integration 8 minus 1 whole square is equal to 2 pi f dash 1. Now fz equals to 1 equals to 0. So the value is 0 because 2 pi I into 0, so it is 0. So this is my answer. And the pole this is the circle and the radius is 2. Question number 17. Let C be the contour clockwise oriented, radius half centered at I equals to root over minus 1, then the value of the contour of integral. So friends, let's draw an axis. This is my axis and this is I and this is my circle whose radius is half. So my pole is z equals to I. So integration z minus I divided by, so my residue I have to find out, residue z tends to I equals to limit z divided by z plus I, this is the minus I, so z minus I into z plus 1 into z. So this portion and this portion is cut, so I get 1 by 2I equal to 1 plus I 1, and I can write this way. This value is 1 into minus 2I into 2, so it is minus 1 by 4I. So I get residue is this, so my integration integration is dz into z to the power 4 minus 1 equals to 2 pi I 4I. So it is cut. This is cut. So I get minus pi by 2. Thanks for watching.